Hi viewers, you're welcome to today's lesson. Did you know with the dimensions of these three fundamental quantities, you can get the dimensions of most of the derived quantities? So firstly, let's define fundamental and derived quantities. Fundamental quantities are quantities that can exist independently, while derived quantities are quantities that are gotten from the combination of two or more fundamental quantities. Examples of fundamental quantities are mass, length, time, temperature, electric current, amount of substance, luminous intensity, while examples of derived quantities are area, volume, speed, force, acceleration, momentum, moment, density, and so on. So let's dive in. We have the dimension of mass to be given as m, dimension of length to be given as L, and the dimension of time to be given as capital letter T. So with these three, we are going to be finding the dimensions of other derived quantities. So let's start. Derived quantities. The first derived quantity we're looking at is area. Area of any shape. Let's pick a shape to be rectangle. The area of rectangle is length multiplied by breadth. Breadth as dth. So we have the formula to be length multiplied by breadth. So the next thing to do is to change this quantity length to the dimension, which is length multiplied by breadth is also a form of length. So we are going to represent it by length. So length multiplied by length is supposed to give us length squared. And we are done finding the dimension of area. The second quantity we'll be talking about is volume. The formula for calculating the volume, length multiplied by the breadth multiplied by the height. So the next thing to do is to change this quantity length, breadth, and height to their dimension. And we are supposed to have L for length multiplied by L for breadth multiplied by L for height, because height is also a form of length. And we are supposed to have L cube. L multiplied by L by L. We have L cube. The third is going to be speed. Speed means distance divided by time. So we are going to represent our distance by L. Distance is a form of length, and the time by T. Therefore, we are going to have L by T. That means length per time. Number 4. Let's pick velocity. We are supposed to, velocity is displacement divided by time. While our displacement will be represented by L, and we have time will be represented by T. Therefore, the dimensions of velocity is L divided by T. The next one will be acceleration. Number 5, acceleration. Acceleration can be gotten from velocity divided by velocity, as we've gotten earlier, is this divided by another time. So mathematically, this is going to give us T squared. So from acceleration, we'll be doing force. We'll be doing for force. We'll be getting the dimensions of force quickly. That's number 6. Force. Force can be gotten from the product of mass and acceleration. So mass multiplied by acceleration. Plus the dimension of mass, capital letter M, multiplied by the dimension of acceleration, which we have gotten here already. So length times square. And we're supposed to multiply everything together to give us MLT minus 2. And we are done finding the dimension for force. Let's go for work. Work is the product of force and distance, or you can say the product of force and displacement. And work, force as we have gotten is M LT minus 2 multiplied by distance, which is another length, and mathematically we are supposed to have L times L squared T minus 2. And we are done finding the dimensions of work. And lastly, we'll be finding the dimension for power. Power is the rate of doing work. That means the work divided by time. And the work is M L squared divided by another time T. So mathematically we are supposed to have M L squared. This is going to be T minus 3. So this is the elementary way of finding the dimensions of quantities. Thank you very much. Do ensure to like and subscribe to this channel. Like the video and subscribe to this channel. I'll be doing another video that's going to show the advanced way of finding dimensions of quantities. Thank you for watching. Bye.